Alright, so in today's video we're going to be taking a look at how to add Bluetooth with button controls to a Skoda Stream radio. This is my latest build and also features a Type-C output which can very neatly be tucked away. Now this will provide wireless charging whilst the phone, while the radio is on, right? So it will disconnect when it's off. So let's see if it reconnects. And you can see we're charging and we're playing. Boom. So let's see. And now I swapped the encoder, so the volume is the other way around, but if you won't do this, yours should be fine. So this is extremely trippy now. And track controls are these two keys. And play pause is scan, right? And if you long press it, it'll become discoverable. Now I'll let Past Dari explain how all this is made, and hopefully he'll go over the diagrams with everything with the iPad and show everything.
Yeah, with the iPad.
How everything's cabled up inside.
Like it's dude, we're the same fucking person. Chill the fuck.
All right.
Okay, I'm just gonna cut you out.
Alright, dude.
Anyway, so getting to the build,
Alright.
I thought about showing everything before adding the case because it just looks a bit nicer. Let's get some more light onto the matter. And yeah, we'll go over, I think, initially the diagram that I've established. And we'll take it from there. Do I have something to point with? Oh my god. So basically we got a 300 megabyte PDF PSD file in Photoshop. And so the first thing I did is actually boost the supply for the amplifier chip, because I found in the datasheet that it has a pin that will output whether it's clipping or not. Now I don't know which one of these it actually is. Maybe it's this one, I don't know. Or maybe it just outputs data, right? Because it does have I²C, I believe. But anyway, so if this starts clipping, it will alert the microprocessor, which is a Freescale part. This one right here. These are all the chips: Fairchild, Freescale, and NXP. Right, so the last one is German, but the rest are American, and it's built in, where is it? I think it was built in Portugal or Spain or something by Vistion. Anyway, so what I did is basically add another capacitor in parallel with the one they have and just yanked the supply right from the connector up to the amplifier. Right, so I've done this using the fanciest silicone wire I could, and luckily I had this in stock, and it is beautifully thick in silicone, right? So yeah, and just to avoid as much vibration as possible, especially this is going in a 1.9 diesel, I've gunked it down, right, just to remove as much vibration as I possibly could. And this is always a pain in the ass, so I've done this in 2 radios by now. The previous one actually did short to some of the pins on the bottom right, so over on this side. But yeah, this one I've done a bit better. I would say I'm a bit prouder of this. Let me see if I can get a good angle. So basically that's what we're after. Just taking the supply as close to the amplifier as possible. Now they had a 3300 mic Nichicon cap, 16 volt rated, so the voltage is rather close to what the car is operating at, but I guess should be fine. And luckily I had another 16 volt 5000 microfarad capacitor, also Nippon Chemicon, so we're packing good brands. And the silicone cable had just its insulation stripped, as you can see down there.
So it's a full continuous strip of metal right up to the amplifier. And I've done this, as I've said, on a previous radio, and I think it sounds a bit better, to be honest, because once you got to like, the volume has 45 steps, and above 30, especially if some thick juicy bass kicks in, right, you won't feel much of a difference, because I think this senses the clipping and just ignores the actual volume you set on the front and just keeps it to as far as it can handle, right? So this should actually help. I do have a video over here with an amplifier from Jesse, and that also seemed to have suffered from too low of a capacitance on the main power lines. And so yeah, basically I've highlighted the 2 pins that are the plus supply, right, for the 2 banks, and negative has a few more pins. But yeah, I'm a bit disappointed by how few pins this has for power, but whatever, what do I know. And so that, I think, covers the extra capacitance I've added. What else can we go over? This is from the pinout on the back, and it's very annoying to cover, right, because it's anyway. This car does have AUX-IN, so I just piggybacked onto the existing connectors, and the car's AUX-IN will still work as regular, and you can actually plug headphones in, and if you want even more immersion, I guess, for the people in the back, I'll think about it. Right, might actually carry some headphones in the car. So that is rather unspectacular. You just have left and right and ground. And luckily there's some nice capacitors here that can act as a very beautiful strain relief. All right, and then we get to the Bluetooth board, a QCC 3008. I have videos up here showing how to program, so you'll need PS tools to rename it and to save the older configuration that's stored in it, right, with this chip. And then there's 2 more other tools to configure the DSP inside of it, so you can add some equalizer to it, but it will slow down the signal path, right? So it will add quite a bit of audio delay. In this case, I haven't done it. Maybe I will, maybe I won't, I don't know. I don't really like how this sounds, but we'll see. My speakers were also very new, so they've actually started sounding a lot more okay recently. You don't need any capacitors, right, because this is all single-ended and floating at around 0 volts, so it's not a biased line, as you might find with the DSP chips inside of the radios, as in my previous Mercedes mods. What else can we say about this? Not much. So it wants a 5-volt supply, and what I want is for that 5-volt supply to actually start when the radio starts and to be cut when the radio is off, right? And I want this because I want it to reconnect when I turn the car on, right? And I want it to automatically connect to my phone. Boom, I'm ready to go. If I have Spotify open, it's gonna play automatically when it finds a Bluetooth connection, so that's just a beautiful way to live. However, I had a problem. So if you can see, we have a jumper here, an unpopulated connector actually, and this has a 5-volt supply, right? So I'm fairly confident I can get 100 milliamps from this. It should be the supply for whatever they're doing over here. But yeah, so initially I took that and powered my board directly. However, when you actually start the car, it does blank all the equipment, right? And it turns off, and it's very annoying because it had a 200, 300 millisecond glitch on this 5-volt, right? Glitch. It just turned off and back on again. So I needed a way to have this survive that glitch, because if a Bluetooth device disconnects, and then wants to connect back to something iOS, which is, by the way, terrible at Bluetooth, it has been for the past, I would say, 10 years, and now it's going to shit completely. Actually, Luke Miani did a video on that, so you can check that out if you want to hate on Apple. Either way, this piss with the cock you've got, this is all I have. So we have these tiny buck modules, right? One of them is glued on top of my capacitor, And they do have an enable line, right, which I've used in my prior mods as well. Actually, let me bring one in and we can talk about it. So these are very nice. So these are very nice, and they do require a slight modification. They will take up to 30 volts input, no problem. Don't do it though. It only says, I think 24 or 22 on the data sheet. But anyway, they will handle much higher voltages comfortably. They will not increase in their quiescent draw. They're very beautiful to work with. And they have this enable line, right? So what you would do in such a mod, let me set you guys down. So what you would do in such a mod is, first of all, bridge the 5-volt output, right? Which is this one. Let's actually zoom in. So you'd bridge the 5-volt over here. Make sure not to bridge onto the ground plane over here, because most of these have the silk screen removed for the writing. Some of them have it in actual ink, but anyway, just be careful. Just bridge this, and what you want to do is either cut this tiny bit of copper over here, or what I like to do, and it's a lot simpler. Oh, and check out how nice my nails are. Yeah, that was again very lucky. So you just want to yank out this potentiometer, and you do not under any circumstances want to drop it in your equipment, which I just have. Fuck. Oh no. Here it is. So you do not want to use any potentiometers in any builds, because these will drift over time. And I've actually had a very serious drift on my iPod Hi-Fi build. I'm not sure if I made a video about it, but I'll link it at the top if I have. And in that case, a constant current, I think it was boost DC-DC converter, actually drifted from 400 milliamps to about like an amp or so. So that got pretty dangerous, and the supply would cut off due to overheating, so it was a pain in the ass. Anyways, you just want to like slide everything off, because this is lead-free solder and it will work flawlessly. Right, so you just have the entire potentiometer area cleared. Make sure to not have any links left over. And that should be the simplest way to configure one of these. Doesn't look particularly beautiful, but it should work. And very importantly, this enable line is actually connected to VIN with this resistor over here, right? What is it? I forget. 30D, I don't know what that is. I'll put it on the screen. But anyway, again, same procedure as before, just remove this SMD resistor, just like so, and give it another swipe just to make sure no conductive debris is left. And you can touch it up with your soldering iron if you want, just to make sure everything's okay. So anyway, I have now went back to using the main supply, right? So VBAT, which I'm taking from the positive leg of this connector, this capacitor, because I don't want to, again, this is the second time I'm doing this. It's not overly pretty. So I'm taking a plus over from that side for the type C charger, which I need for my phone charger, right? I have a MagSafe phone charger, which I want to be on when the radio is on, right? And I'll have a little wire. You'll have seen it in the previous section, so I won't go into it. Future Dari will have showed that in detail, I would assume, knowing him. And so basically I'm taking the full 12 volts that's always present, and I'm taking this 5 volts that's only present when the radio's on and has this like half a second glitch when you start your engine, feeding it with a diode into a capacitor, which I've added here. And 22 mic 16 volt is way too much. You could probably get away with anything above 2 microfarads, because now when the supply is off, right, when this 5 volts are off, it will stay on for, I don't know, best part of a minute actually. So you can easily survive that glitch at startup, and your Bluetooth will not disconnect and reconnect, pissing off iPhones, right? Because they will really not accept the connection. And then you have to go into your menu
Takes like half an hour. It's horrible. The UI is disgusting. I hate it. Anyway, so it will stay connected. It should work just fine. And this is the tiny diagram showing how that works. Basically, nothing too fantastic over there. What else? I think this covers the western part of this diagram. Here's how the amplifier looks. I've taken a little snapshot of it. And yeah, no, I think that's about it. And let's go over the type C supply. And again, this one also needs to be on when the radio's on and off otherwise. And I've actually bought an IRF Z44. I should have another one here actually. So an IRF Z44N, yeah, International Rectifier, I think is the brand. I'm hoping this is legit. I actually have a box of semiconductors where I have some from eBay, but those are like super fake. The font is shifted, is tilted, and barely fits the MOSFET, right? So these are just N-type, meaning they switch to the negative, and very low gain. So you can feed these 3 volts and they will turn on, and they should do ample current, right? Where technically this can do 65 watts at most, but it's definitely not going to do it on 12 volts. And as for wires, I have these very soft silicon wires from the Type C to Type C cable that I bought to route next to the radio, right? And I've shortened it, and now I have some very nice silicon cables, which are quite thick and very flexible and very nice. So I've taken basically a ground from here. Should stop saying basically that often. Or we do a drinking game. You guys choose. So the way this works is the following. I'm just taking VBAT right up to the Type C module, and then the negative will go through this MOSFET down to ground, and the VDD 5 volts will have a pull down just so it turns off quickly, and 10K should draw very little current, so it should be fine. And this is kind of how it looks with the fake MOSFET I've used in the previous one. Ah yeah, 0.5 milliamps we're going to draw, so not a big deal. And this works actually very nicely, I have to say. I'm quite proud. And these will do power delivery, and I'm not sure if they'll do quick charge over the Type C, but they're very nice modules, and I'll try and link a search for them on AliExpress. And now on the previous radio, I've tried to screw this onto the side of the case, but that was a pain in the ass, required a lot of screws. And I've had radio builds come back to me because usually the flash dies from the heat that's present in these radios. And the silicone was still, like after 3-4 years, was still very rubbery, and it resists high temperatures superbly. Do not, and I repeat, do not use hot snot. At 40 degrees, that shit will melt. All your parts will fall down, and you'll short stuff out, and you will set fire to your vehicle, or other people's vehicles for that matter. So only sanitary silicone, and this polymer, I forgot what it's called. I'm going to put it on the screen, right? It's not acidic, right? So this has, it hardens still as a gel, as a like rubber, but it's a lot firmer, and it will get into like tinier crevices. It's and it hardens a lot slower, right? So yeah, pick your fighters. This should also last very well at high temperatures, although I have not tested this at high temperatures that much. But the sanitary silicone, as long as you get the most expensive one, should be super chill. All right, and yeah, let's just go over right, we have the negative line coming from a random spot going into the MOSFET, and right, that would be the negative. You can see the little negative sign on that. And as for the gate, we're feeding it from this 5 volt line, and as for the positive, I'm taking it directly to the connector over here at the bottom. I'll see if I can gunk these down even further. I'll find a way to wrap them around.
Although this is a bit worrying. I don't want this vibrating. I'll see what I can do about it. Anyway, future Darius problem. And so last but not least, what I've done in this one is actually also swap the encoder, and I had to cut it ever so slightly. But this is very pornographic. I'll try and write on the screen how many steps this has, but it's one of those fewer than regular stepped encoders, and check out how this sounds. So it is very pornographic as compared to the old one, which was very soft and mushy. So it actually had one of those rubber membrane buttons inside of it, which I guess why not. But the clicks are very horrible. They have almost no detent. So anyway, I'm hoping, because this is a different encoder, I'm hoping it works the same. I think it does. I haven't measured it too intensely. And I managed to skew it ever so slightly, so I'm not super proud of how well I've done that, but again, good enough for the girls I go out with. So, last but not least, I wanted 3 buttons to control the Bluetooth module, and in this case, it will be scan for play pause, and next and previous for the track navigation. And yeah, in this case you will have to, if your radio hasn't been in the car before, you will also have to route the right key, because that's how you input the code. So that was a pain in the ass to do on the first one, but if you have your working radio, put it in the car, add the code, and then when you'll re-add it to the car, it will actually remember the car and not ask for the code again. It'll self-activate the second time around. And so definitely do not forget the code, because otherwise you need to whip out this key. And on the previous one, I've actually added a secret key behind the encoder. I'll add a picture. All right, so this is the secret button I'm talking about. Boom. Right, so that is actually linked to this key, so you can now input the code when you're done typing it out. And then once you're done, you can just hide it back up. Boom. No one knows about it. All right, back to the program. Of it right now, I'm actually quite proud of how that turned out, and it clicked very nicely. It was kind of cool. But again, 2 hours that I really did not want to spend. So we're talking about 6 cuts to be done, right? 1 over here, 1 for the play button, 1 for each of the play and for the next and previous buttons, and this one on the right side. And we want to reconnect the button matrix that we've destroyed. We'll just need 1 link, and that will have to go from here right over on this side. You can actually scratch the via a little bit and poke right into it. Then you have to reconnect to this trace, this one that we've cut over here. You have to reconnect to it, and then all the way to the left. And they have these nice test pads next to the buttons. Just tack onto that. We should be able to see it over here if we have the right orientation. We do. So over here next to switch 1023, going down, and again I have Celastic this down so it doesn't vibrate and crack off. Over here I've connected it. Now you can see the cut at the top, and over on the right side. So this is the only connection you're going to need. And as for the buttons, some button connections are on the top side, so play, previous, and actually just play in previous. So I've also used this tiny enamel wire, right, taking it from here through a via, and from this side, right, switch 1018 over to this via. And again, I've secured it down, taken it out, and then we're going into hard big copper cables, as well as these two which connect directly to the board, right? And I've elastic these here, and it holds very nicely, I have to say, right? So it really does hold in, and we're not going to have this kind of forces acting on it, but yeah, quite proud of how that came out. And one thing you also have to remember is to not connect these to the board right now, because you have to pass them through this. And on the previous one I did actually cut these pieces of metal, just I mean, these are strong enough as they are, but I'm very ashamed of that. Now, I told you guys as well. Anyway, a disaster that was. So just connect it, route the cables properly, and then link them to the Bluetooth board. And one last thing we have to talk about is disabling the mute on the Bluetooth board. So if this doesn't have any sound, it actually turns off the little Class AB headphone amplifier that it has over here. This is, I think, a Texas Instruments part. Sounds beautiful. But once you disconnect it, right, due to this being like a rather budget car, I don't know why, but there's a lot of interference on the jack, right? So especially this is going all the way to the like armrest. It picks up a crap ton of interference, and it makes a very, very annoying buzzing noise. It is totally unlivable, especially if you're on high volumes, but even at low volumes you can hear it. So what you want to do in that case is prevent this from muting the amplifier. I've tried the elegant route through software, couldn't get it to work, right? I have a pretty old software suite, and these chips are on their way out, right? They're still not deprecated, they're Bluetooth 5, but anyway, what is simpler to do is just disconnect the mute line, right? So on this type of board, you'll want to cut that trace, and I think I have another one. Yeah, so this trace. And you have to bridge these two pins, right? The enable pin and the PVDD pin. And that's fairly straightforward. If you have like a sharp soldering tip, it should be doable, right? It's not the easiest, but also not the hardest thing in the world. So you can see I've bridged it there. And now this amplifier is always on, and it has a very low impedance output, so it just really yanks the left and right channels down to ground. Very quiet, very, very quiet. I actually have these in parallel with Airport Expresses, and those do not stand a chance, right? If this is on and playing a muted song, you will not be able to hear any airplay coming through. This is how low impedance these are. So yeah, I think I'm actually done. So I'll probably also heat shrink this and just have it sit somewhere in the radio. Nothing too spectacular. I don't feel like screwing it down because I'd have to, it's too complicated. And it is very nice in this particular radio because everything below this is your space, right? So you have a lot of volume to work with. So yeah, if you have any questions, or if you want to have this done to your Skoda radio, this was a pain in the ass, by the way. This was like 20-30 hours of work. That's disastrously complicated. But yeah, have a good one.